People usually think all that thermal management needs is some coolant, a pump, and some hoses and the radiator. But in order to make a system very optimized, it's a lot more complicated. There's a tremendous amount of packaging work to do because we have almost 100 parts that we need to place in the vehicle. We have to do a lot of simulation work, a lot of testing. So all of this is very complicated, and I don't think it's always something that people expect. My name is Nico Bell. I'm managing the thermal system in the vehicle, which includes 4 subsystems. The first activity that we do is to cool down what we call powertrain and power electronics. An electric motor is a lot more efficient than a gas-powered engine, but it still rejects a lot of heat. We need to make sure that the motors are not overheating and that we are still able to have the maximum performance that we can from the vehicle. We are also cooling what we call power electronics, which is the components that are needed to provide low voltage power to the vehicle and also to provide charging in some conditions in the vehicle. We also cool down or heat up the battery in order to work in what we could call the smooth range. Batteries are typically happier between, let's say, 20 to 35 degrees Celsius. So if it's warmer, then there can be some safety issues and it will take longer to charge a vehicle, or we might not be able to get the performance in terms of acceleration or top speed, for instance. If it's too cold, we also cannot use 100% of energy stored in the battery pack, which might have an impact on range. And we might not also be able to get all the performances from the vehicle, specifically in terms of acceleration. When we have the cabin cooling and heating, it is quite critical. It's not nice to be feeling warm or cold, and so we're working hard in order to make sure that the car can provide the best comfort possible to the passengers. For instance, we have a 4-zone air conditioning system, which means that each passenger can decide the temperature that they want the air to come out of the vents. They can also decide if they want the air coming out of the foot or towards the face. This is a very difficult thing to implement, specifically in the auto mode, and so we tried to make this car as user-friendly as possible and also making sure that it provides the best comfort that can be seen in class. Finally, what we call air management and heat exchangers. So there are 2 different types of airflows that we have in the vehicle. One of them is to cool down the powertrain, the motors, the batteries. And in order to do this, we have radiators in front of the vehicle that are using the airflow from outside in order to cool down the coolant, in this case the water that we are using. The second type of airflow that we have is the air going to the passengers in the cabin. So the air exiting the vents that we can see on the dashboard, on the console, or on the doors. So first it's what we call intake. So where does this air come from? Does it come from the cabin or does it come from the exterior? The air then will go through the vents that the user wants to get air from. And we can control this manually, or what we can also do is have what we call the auto mode. Then we will be computing and deciding where to send the air. So those are the 2 different types of airflow that we can see in the vehicle. The FF91 is a very complex vehicle. It's a very luxurious vehicle, and so we have some features that are also very complicated to implement. There are also other parameters that can depend on the execution of this thermal system. So if it's not done properly, we can feel, for instance, some vibrations from the system, which might not be acceptable. So in order to design the system properly, there are a lot of work that needs to be done. The first step is to do a very good simulation model. So if we can simulate the different components that we have and how much heat they can reject, like for instance motors or batteries, then we can size the different components that we have in the vehicle correctly, and we can optimize them. So what that will do is that we can save weight, save current, really help to optimize the system at the component level. The next step is to make sure that we develop a very good control strategy, to make sure that we use them properly, that we don't overuse them, so we only use whatever is needed, so that again we can save some energy and increase the range at the end. Then we'll do bench testing, which typically happen in our engineering facility here in Los Angeles. We also sometimes rely on our suppliers to help us do some of this testing. The last step is to be testing those 3 subsystems at vehicle level. Our car will be sold in many different areas, so we need to make sure that we can perform as expected in all those different conditions. That means going on test trips, so we can test in very warm weather, for instance in the Death Valley, in Las Vegas. We can test in very cold weather, in Minnesota, in very humid weather in Texas. And we can also do some of this testing in wind tunnel, which is a very controlled environment, so it's great for final validation. I've been working on this car for many years now, sometimes on weekends, in evenings, so it's been a lot of work and also not always easy. Yeah, I'm really excited, a little bit anxious too, to see the car in the hands of customers. I think that will be a very rewarding moment, but I think that shows that we should never give up and work hard, and we can achieve what we really strive for.